Right. Okay. Now, can you remind me what we were doing? I think we were discussing about algebras, right? And
Yes, sir.
sigma algebra.
Yes.
And I think I have asked you to look into the examples, and also I think to the definition of sigma algebra as well, right?
Yes.
Okay. Uh, no, you have to remind me the last example that we were discussing. දැන් පන්තියේ නෝට් එක තියෙනවනේ මට
Sir,
බලලා
finite subset. ඒකද?
okay, I think what you mean is this, right? So we consider this example where, you know, like we have sample space omega, right? And then we take the collection of all the subsets A, where A is equal to either omega, so either empty set, or its complement is finite, right? Is this the one we
Yes, sir.
Yes.
right? And then what we have observed is the following, right? If we take any two sets, no, I think this is not what we considered, right? This is the initial one that we considered, but then we refined it to something else, right? What is the final one?
Yeah. A subset.
Sorry?
A is finite or A complement is finite.
Exactly. So that is that is where we ended up with, right? A or A complement is finite, right? Right. Then what we have observed is the following, right? First of all, the empty set and omega belongs to F. Why? Empty set is finite, and therefore under this provision, right, empty set belongs to F. On the other hand, omega may not be finite, however its complement is equal to empty set, which is finite, and therefore omega also belongs to F. All right. එහෙනම් නැත්තම් chat එකක් හරි දාන්න. මොකද මේ right. And then we also observe the following. If A belongs to F, then a complement also belongs to F. Right? Why is that? Because this definition is symmetric, right? That's how we can think of it. sorry මම ඇහෙනවනේ
Oh, sir.
sorry okay මට පොඩි හදිසි කෝල් එකක් බලාපොරොත්තු වෙමින් හිටියේ ඒක
එහෙනම්
දැන්
සර්.
ආවේ right okay right now now do you understand what I mean here this definition is symmetric in the sense that either a if a is in f then its complement also in f right this is something we discussed last
Yes,
time
sir.
but I just want to understand why it follows from this definition okay so this is because the definition is symmetric in some sense okay definition of f is symmetric okay this is actually some you know like not a precise statement but that's how, an intuitive way to understand okay is symmetric over complements right because if a is there then its complement is there I think we wrote down a detailed proof of this right
Yes.
okay and so I'm expecting you to write down that sort of an argument here but this is just a reminder okay right and then what else did we observe we have observed that if a and b are in f then their intersection is also in f right and as a consequence of 2 and 3 we also have that for any two elements in f their union a union b is also in f right this is something that we don't have to prove it's a consequence of 2 and 3 I think this is where we were right when we stopped the last lesson
Yes, sir.
okay
Yes, sir.
right uh, now by now you might have uh, more examples of algebras do you so anyway the conclusion of this observation is that f is an algebra right algebra over this omega right and this is called yeah so this is an algebra okay so that's right any other examples you have seen yes
නෑ එකපාරටම නිකන් ඇහෙන්නේ නැතුව වගේ සර්.
Ah,
දැන් ඕකේ සර්. හරි සර්.
okay right so any other examples that you have observed while going through the book right now here's an important idea okay now which I have already presented in some sense when we were considering this example okay what is the idea now I think we did not come to this definition right away can you remember we started with a set and we checked what sort of sets can be constructed by applying these operations that is the complement the inclusion of the empty set and omega in F, taking the complements of the sets in F, and then taking the intersection of sets in F, right? And starting with certain collection of sets, we can apply these operations, and we will continue until we are closed under these operations. And that way, we can generate an algebra starting from a certain collection of sets,
Yes, sir.
right? ඒක තේරෙනවද අනිත් දෙන්නටත්?
Yes.
Okay, so what is this example? We can start with some sets with some collection of sets with a collection of the collection of certain subsets of omega, right? And we will do the following. What we have to include empty set and omega to the collection, right? And then we have to include complements, right? And then finite intersections. If we get new sets after these constructions, then we have to repeat this process, right? Until no new sets are created. So after we complete this, we will have an algebra which we call to be generated by the initial collection, okay, which we call, which we say to be generated. Okay, so here's the keyword, generated by the initial collection. All right. Now, of course, this is not a complete description, but do you have a rough idea of what this means?
Hmm.
Yes, sir.
Okay.
Hmm.
මට දැන් ඕගොල්ලෝගේ නම් මතක් කරන්න ඕනේ පොඩ්ඩක්. මොකද පන්තියේ නම් ඇඟිල්ල දික් කළා කියත හැකිනේ. චාමික, චානක and
Ah,
sorry. So what should I call
Jayani.
Jayani, right? Jayani, Chammika, right? Chammika or Chamika?
Chanaka.
Chamika, Chanaka, right?
Anaka.
Ammika.
Chammika and Chanaka.
Yes, sir.
Okay. Sir.
Dimel කියලා හරි
Oh, sir.
යන්නේ.
Yes, sir.
Chammika, Chanaka and Jayani.
Yes.
Right, okay. All right. Now let's look at an example, okay? Now, let's take omega, the sample space, to be A, B, C, D, E. Okay, and consider the initial collection of subsets, let's say AB, okay, AC and BDE. Okay, right. Starting from this collection, okay, can you construct
Hmm.
all the sets that you can generate by applying these operations and hence obtain an algebra? Okay, so you don't so we will start by AB, AC, B, D, E, right? Then what do? We apply, first of all, we need to include what? The empty set and the,
Finite.
first of all, we have to include the
Yeah.
empty set and the
Empty
Omega.
set.
Omega.
right? That is A,
Omega.
C, D, E. Then we apply the complements and take finite intersections of all the sets we can take, create from these, right? Now, can you do this process and see what sort of a collection you will obtain? Right? Then the complements will be,
Okay, sir.
yeah, the complement of AB, right? Then the complement of AC, complement of this one. Well, these two are complement to each other, right? Therefore, you don't need to have include these two in, right? Other complements. Right? Then, of course, you will have to take intersections, right? Okay, and we know that we have to take only intersections of two sets, right? Because well, actually, no. I mean, okay, I take it back. Okay, sorry. We have to construct finite intersections, of course, yes. Because if it is closed under finite intersections, then it's enough to check whether it is closed under the intersection of uh, taking the intersections of two sets. But in general, to construct this process, we can speed it up by taking all the finite intersections. Okay, for the complement of this one is CDE, right? Okay, and then
yes.
AC වල කම්ප්ලිමන්ට් එක තියෙනවනේ සර් BD BD වල කම්ප්ලිමන්ට් එක AC
ඒක
තියෙනවා.
තියෙන.
oh, so this is already there, right? So the complement of this one is this, and therefore the complement of this one is this. We don't need to include these two, right? Okay. So it might be useful to organize these in pairs, right? The complement and the set and its complement, right? So what we have here is this one, and so I'm going to put it over here. Okay, this is the complement of this one, and then of course these two are complement to each other, right? Right. Okay, now we know that. Then we have to take all the finite intersections, right? Now what sort of sets can we take create by taking finite intersections? Now a thing to observe here is that if we have the set and its complement as well in the finite intersection, then this intersection is going to be empty, right?
Yes.
Therefore, if we include this set in the intersection, we don't have to include this one in the intersection, because that would create only the empty set, right? So we have the option of either including this or its complement. Okay, so star here means either the set itself or its complement. Okay, right? So we have the option of including this one or its complement, right? And then including of this one or its complement, right? And there is no point of including this one or its complement, because that will either generate the empty set or taking the intersection with the universal set is same as I mean the original set, right? So in this case, it's much more easier. We have to only consider the intersection of this one with this one, intersection of this one with this one, right? This one with this one, and this one with this one, right? Because we have two choices here, two choices here. Now, what are the sets you will generate?
සර් මේ පොඩ්ඩක් ඇහුන්නේ නැහැ අන්තිම ටික මේ empty set එකත් එක්ක කොහොමද finite set එක ඒක අයින් කරේ?
මොකද දුව අයිත් කියන්න
අර සර් අන්තිමට කියපු ටික තේරුනේ නැහැ.
මේක ඕන්න නෑ කියන එකද
ඔව් සර් ඒක
ඉතින්
තේරුණා.
අපිට මොකක් හරි මෙහෙම ඉන්ටර්සෙක්ෂන් එකක් තියෙනවා A1 A2 ඔය වගේ හරි so we have a intersection but if we include empty set into this whole thing reduced to empty set right
Yes sir.
okay on the other hand if we include the universal set into this intersection reduced to this part right
Yes sir.
therefore now when we take finite intersections we don't have to worry about these two sets we only have to worry about what sort of intersections can be created using these
Yes sir.
right and again there is no point of including a set and its complete both a set and its complement in the intersection because that will create only the empty set
Yes sir. I get it. Thank you.
so now if you consider all these facts together you will realize that there are only 4 intersections you have to consider right this one and those 4 intersections are this one with this and this one with this right because there's no point of including this one and this right and this one with this and this one with this those are the only 4 those are the only 4 possible ways of creating a new set by taking intersections and then of course yeah that's all right think about it
Hmm.
now what sort of sets will you create then what will happen if you take AB intersection AC
It's just a element.
right then what about AB intersection BDE
B.
B what about AC or rather CDE intersection AC
C.
C right and then
Just
CDE intersection BDE
DNA.
D and E right
Yes.
now because you have obtained new sets now you have to take the complements of these right so you have to repeat this process now okay now you have when you took intersections you created new sets which for some of which the complement is not contained in the collection right and if you wish to obtain a collection which is closed under complements now you have to include the complements of these right then again you have to include the complements that would be what the complement of this one
Hmm. Um,
okay so I'm going to summarize the collection that I'm creating up here okay so we have A right and then its complement is B, C, D, E, right?
B, C, D.
Yeah. And then we have B, right? And its complement is what?
ACD.
Hmm.
A, C, D, E,
A, C, D.
right? And then we also have C, right? And then we have A, B, D, E. And then not only that, right? We are going to get more.
Hmm. D.
D, E, right? And its complement A, B, C,
Hmm. Yes, sir.
okay?
Oh, sir.
Yes. Okay, now you can think of what are the sets you can create by taking intersections of these, right? Now, no point of taking intersection of two of these, right? Because that's how you created these sets, right? So maybe it can be, these guys can be listed in the second layer, right? Because these are the new additions to the collection. Okay, right. Okay, right. Now there's no point of taking intersections of these guys, right? So that's how we took, right? And now what will happen if we take intersections of any two of these? Right? So I mean, the taking the intersection with a singleton set, which will generate either the singleton set or the empty set, right? Therefore, there is no point of considering these intersections. So what you have to think of are the intersection of these two, and the intersection of all three.
Okay, sir.
And there is another one here, right? Now what you have to make them බලන්න මේක intersections ගන්නකොට හරිද? මේක intersections ගන්නකොට මේ set එකයි මෙන්න මේ layer එකේ තියෙන set එකයි එක intersection එක ගන්න ඕනේද? මෙන්න මේ layer එකේ තියෙන set එකක් ගත්තොත් අපි මොකක් හරි A කියලා. හරිද? ඒක මෙන්න මේ layer එකේ තියෙන set එකක් එක්ක intersections තිබ්බොත් B1 intersection B2 ඔය වගේ තිබ්බොත් හරිද? අපි දන්න දේ තමයි මෙන්න මේ layer එකේ තියෙන හැම set එකක්ම මේ උඩ තියෙන sets වල intersection එකකින් ඇවිල්ලා තියෙන්නේ. මේ B1 කියලා කියන්නේ මොකක් හරි ආයිත් A ලගේ intersection එකක් නේ. මේ B2 කියලා කියන්නේ ආයිත් A ලාගේ ඉන්ටර්සෙක්ෂන් එකක්. එතකොට ආයිමත් හැදෙන්නේ මෙන්න මේ A ලාගේ ඉන්ටර්සෙක්ෂන් එකක් විතරමයිනේ. මේ උඩ ලේයර් එක අපි A කියලා ගත්තොත්. ඒ කියන්නේ මේ උඩ ලේයර් එකේ තියෙන සෙට්ස් එක්ක දැන් යට ලේයර් එකේ තියෙන සෙට්ස් එක්ක ඉන්ටර්සෙක්ෂන් එක අවශ්‍ය නැහැ. හරි ඒ
Okay,
මේ
sir.
හරි මේ ටික ඒ වගේ කම්ප්ලිමන්ට්ස් එක්ක
ඒකත් ඕනේ.
ඔව් ඒ වගේ කම්ප්ලිමන්ට්ස් ටික එන්න පුළුවන් නේ. හැබැයි ඒකට හොඳම ට්‍රික් එක තමයි මේ ඉන්ටර්සෙක්ෂන් එක දාන වෙලාවෙම යූනියන් එකක් දැම්මනම්. මොකද මේ වගේ එකක් කියලා කියන්නේ. හරි ඒ ඉන්ටර්සෙක්ෂන් මේ ඒ කියන්නේ මේ උඩ තියෙන ලේයර් එකක්. ඒක මේ යට තියෙන සෙට් එකක මෙන්න මෙහෙම හදපු එකක කම්ප්ලිමන්ට් එකත් එක්ක ගත්තොත් ඒ කියන්නේ මේ තියෙන ඒ ඉන්ටර්සෙක්ෂන් මේ තියෙන මොකක් හරි ඒ ලාගේ ඉන්ටර්සෙක්ෂන් එකක කම්ප්ලිමන්ට් එක ඒ කියන්නේ ඒ ඉන්ටර්සෙක්ෂන් මේ තියෙන මොකක් හරි ඒ ලාගේ කම්ප්ලිමන්ට්ස් වල යූනියන් එකක් නේ. හැබැයි ඒ ලාගේ කම්ප්ලිමන්ට්ස් කියන්නේ තායිත් ඒ ළමයි. හරි මොකද ඒ කියන එක අපි කම්ප්ලිමන්ට්ස් වලින් ක්ලෝස් කරලානේ තියෙන්නේ මේ ලේයර් එක. හරි ඒ තියෙන මේ එතකොට මේ තියෙන මොකද්ද ඒ ඉන්ටර්සෙක්ෂන් A1 වගේ යූනියන් එකක්. ඒ කියන්නේ අපි මෙන්න මේ ලේයර් එක මෙන්න මේවත් එක්ක ඉන්ටර්සෙක්ෂන් එක ගන්න ඕනි නැහැ. අපි මෙන්න මෙහෙම කරොත්. මොකද්ද අපි මේ A කියන ලේයර් එක ගන්නවා. ඒකේ කම්ප්ලිමන්ට්ස් ටික දානවා. ඊට පස්සේ ෆයිනයිට් ඉන්ටර්සෙක්ෂන්ස් ටික හදනවා. ඊට පස්සේ මොකද්ද කරන්න ඕනේ? මෙන්න මේ ඉන්ටර්සෙක්ෂන්ස් වලිනුයි මේ තියෙන ඉන්ටර්සෙක්ෂන්ස් කියන්නේ මෙන්න මේ උඩ ලේයර් එකයි මේ උඩ ලේයර් එකෙන් අපිට දෙවෙනි ලේයර් එකේ පළවෙනි එකෙනුයි එන සෙට්ස් වල යූනියන් එකෙන් හදන්න පුළුවන් ටික දැම්මනම් හරි නේද ඊළඟට. මේ තියෙන්නේ ඒ වගේ වනේ. උඩ ලේයර් එකේ ඉන්ටර්සෙක්ෂන්ස් මේ තියෙන්නේ. ඒ වගේ යූනියන්ස් වලින් මේ තියෙන කම්ප්ලිමන්ට්ස් ටික. අය මේවත් එක්ක මෙන්න මේ ටිකේ ඉන්ටර්සෙක්ෂන්ස් ගන්න ඕනේ නැහැ. මෙන්න මේවත් එක්ක මේ ටිකේ යූනියන් එක මෙන්න මේ ටිකේ යූනියන්ස් වලින් හදන්න පුළුවන් එක මොනවද කියලා බැලුවා. So in other words, my suggestion is because we are looking at a collection which is also closed under unions, right? So let's complete it taking unions as well. මෙතනම unions උත් දාගෙන ගියොත් එහෙම අපිට වැඩේ ඉක්මන් වෙනවා, fast වෙනවා. ඇහෙනවද මාව?
ඔව් සර් එහෙනම් සර්.
හරිනේ? But you understand that there is a process that you can carry out, right? And so eventually you will end up getting new sets. And hence obtain a algebra. Can you try to complete this now?
Okay, sir.
Right? So maybe I'm going to leave this as a homework, okay? Because I think otherwise it will be a waste of time for me to wait until you complete it, right? Emily?
Okay, sir.
Right? But I just wanted to point out to you something. Uh, uh, I mean, a process. Okay, and it's very important that I think in every year I have given a problem like this in the exam. Okay, given a collection, you can compute the algebra generated by this collection by carrying out a computation like this. Okay, so I hope now you will also you can hear me. Can you hear me?
Yes, sir. Okay.
Yes, sir.
Sorry, something happened to my connection. Okay, right. Now, please look at the past papers. Did you find the past papers?
So, no, sir.
Okay, you should. Okay, examples of this type, and try to complete them. We will continue this discussion after you have tried some problems. Okay.
Right.
Okay, but this is something that you all have to practice, right? Carrying out these computations and you know doing this. Okay, but after you have tried, I think we can discuss it in detail. But for the first place, I think it's better for you to carry out a computation. හැමෝටම මේ අයිඩියා එක තේරුණාද? හරි, අපි කරන්නේ මොකද්ද? කම්ප්ලිමන්ට්ස් ගන්නවා, ඉන්ටර්සෙක්ෂන්ස් ගන්නවා, යූනියන්ස් ගන්නවා. ওই ටික කර 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 යනවා ආය අලුතෙන් සෙට්ස් හැදෙන්නේ නැති වෙනකම්. හරි, ඒ ටික සම්පූර්ණ කරාට පස්සේ අපිට මෙන්න මේ සෙට්ස් ටික තියෙන ඇල්ජිබ්‍රා එකක් හැදෙනවා.
ඔව් සර්.
නේද?
No, sir.
Right. So now here's an important thing. Okay, now this algebra, the algebra, we create in this way, has the following properties. Okay, so what is it? දැන් මොකක් හරි අපි කරන්නේ මෙන්න මේ වගේ දෙයක් නෙමෙයි. මෙන්න මේ sets ටික අරගෙන we take these sets, right, and we ask the minimal conditions for an algebra to contain these sets. Right, so what it means is that the algebra generated by these sets, okay, okay, so when we say the algebra we create in this way, what we mean is the algebra generated by these sets. Okay, okay, right. So this algebra has the following properties. First of all, now any algebra, okay, let's call this these sets, let's call this collection of sets A. Okay, any algebra containing A must contain these sets, right? The algebra generated by these sets. එහෙම නේද? Do you understand what I mean? Suppose A is this A1 up to A2 up to AK. Okay, okay, and we continue this process and obtain something larger. Let's call this A tilde. Okay, which is algebra. The all the sets is the set of all sets that we create as above. Okay, that we can create as above. Okay, right. Now what we have observed, what we claimed is that this is a algebra, right? This is an algebra, right? Certainly this algebra, let's call this algebra sigma A. sorry, we have given it a name, right? A tilde. Okay, this is an algebra, and this algebra certainly contains A as a subset, right? ඒක හරිද?
Okay.
හරිනේ, මේ අලුතෙන් හදපු සෙට්ස් ටික අපි පටන් ගත්ත සෙට්ස් ටික අනිවාර්යයෙන්ම තියෙනවනේ නේ. අපි මේ ටිකෙන් පටන් අරගෙනනේ අලුත් ඒවා හැදුවේ. එහෙම නේද?
ඔව් සර්.
Therefore, we already have these sets in the new collection. Okay. අනිත් පැත්තට හිතන්න F කියලා කියන්නේ F is a algebra containing A. කියන්නේ A ගේ තියෙන sets ටික ඔක්කොම තියෙන algebra එකක් F කියන්නේ F කියන්නේ A ගේ තියෙන elements ටික ඔක්කොම තියෙන algebra එකක් කියලා හිතන්න. ඒ කියන්නේ A is a subset of F and F is an algebra. හරිද? මාව ඇහෙනවද?
ඔව් සර්.
right?
හරි.
දැන් කල්පනා කරන්න මේ A tildeව හදනකොට අපි apply කරේ මෙන්න මේ algebra එකක තියෙන operations ටිකනේ. We have applied only the operations of an algebra, right? Complements and intersections and unions. Therefore, every set we create that way must also be in F, right? දැන් මොකක් හරි algebra එකක මෙන්න මේ sets තුන තියෙනවා නම් මෙන්න මේ හදපු sets ටිකත් අනිවාර්යයෙන්ම මේ algebra එකේ තියෙන්න එපානේ. මොකද we have already taken an algebra and it is closed under these operations. ඒ කිව්ව කතාව හරිද? Okay, then my claim is this. Okay, then A tilde is also contained in F. If we start with an algebra which already contains A, then all the sets we have created are also in F. Chamika, do you understand what I just said?
Yes, sir. Yes, sir.
Chanaka, what about you?
සර් තව පොඩ්ඩක් පැහැදිලි කරන්න පුළුවන් මට තියෙන්නේ.
Okay, what about Jayani?
ඕකේ සර්.
Okay කිව්වේ?
තේරුණා.
මොකද තේරුනේ? right? Jayani කියන්න බෑ. Yes, Jayani, what do you understand? දැන්
අපි සර්
අපි මොකක් හරි මෙම sets ටිකකින් පටන් ගන්නෙ නේ. right? ඒකට අපි මොකද්ද කරන්නේ? මේකේ complements ගන්නවා නේ. complements ගන්නවා. intersections ගන්නවා. unions ගන්නවා. finite. හරි? ඊට පස්සේ අලුත් set හදෙන්නේ නැති වෙනකම් මේ ටික repeat කරනවා නේ. yes, Jayani? Jayani?
ඔව් සර්. ඇහෙන්නේ නැතුව ගියා.
හරි, දැන් ඇහෙනව නේද?
හරි. ඔව් සර්.
හරි? right. So what we have is this නේ. අපි A කියලා collection එකකින් පටන් අරගෙන මෙන්න මේ process එක apply කරලා අපි A tilde කියලා අලුත් ලොකු collection එකක් හදනවා. So this collection certainly contains A, right?
Yes.
Jayani?
Yes sir.
Okay, right. Now I claim the following. This collection has the following properties. First of all, A tilde is an algebra. එක හරිද? මොකද අපි මේකෙන් අලුත් මොනවත් හැදෙන්නේ නැති වුණාට පස්සේ that means this collection is closed under complements, closed under finite intersections, right? And therefore it is an algebra. ඒක හරිද ජයනිදුව?
හරි සර්.
Right. ඊළඟ දේ තමයි certainly this one contains this. So it is an algebra which contains A. So we can summarize these into a single statement by saying A tilde is an algebra containing A. Right? ඒක හරිද? Is this all right?
හරි සර්.
Yes, sir.
නිකන් චකිතෙන් හරි කියන්න එපා. This should be absolutely like okay.
තේරුණා සර්.
චමෝද් කවුද? චම්මික චානක
තේරුණා සර්.
හරිනේ? Right. But then is the next one is the important point. Okay. Then හිතන්න මෙන්න මෙහෙම. මොකක් හරි algebra එකක් තියෙනවා කියලා කියන්නේ මේ ඒව contain කරන. Okay, suppose F is an algebra which contains A.
හරි සර්.
හරිද? දැන් අපි මේ A tildeව හදනකොට දාපු operations ගැන හිතන්න. අපි කරේ මොකද්ද? complements ගත්තා, intersections ගත්තා, unions ගත්තා. හරිද? එතකොට දැන් අපි කරලා තියෙන්නේ මෙන්න මේ F ගේ තියෙන sets ටිකක් අරගෙන අපි ඒකට algebra එකේ operations දාපු එකනේ. එහෙනම් මේ හදපු හැම සෙට් එකක්ම ඒ කියන්නේ මේ A tilde වල තියෙන හැම එකක්ම should be in F. Right? Then
අන්තිමට කියන්න තියෙනවා.
sorry
අන්තිමට කියව තියෙපොඩ තේරුණා. අන්තිම ගොල්
දැන් අපි A ගේ sets ටික අරගෙන අපි මොනවද කරේ? ඒකේ complements ගත්තා. හරිද? දැන් A ගේ තියෙන sets ටිකක් අරගෙන complements ගත්තොත් ඒ කියන්නේ අපි F ගේ තියෙන sets ටිකක් අරගෙන complements අරගෙන තියෙන්නේ. එතකොට ඒ හදන sets ටික F වල තියෙන්න එපායිනේ. F කියන එක algebra එකක් නේ. හරි? ඊට පස්සේ අපි මොකද්ද කරේ? intersections ගත්තා. එතකොට ආපහු intersections ගන්නකොටත් අපි කරලා තියෙන්නේ A වල තියෙනවා කියන්නේ ඒව F වල තියෙනවා. F වල තියෙන sets ටිකක intersections අරගෙන තියෙන්නේ. හරිද? හරි? ඔය වගේම finite unions ගත්තොත් ආයෙමත් අපි කරලා තියෙන්නේ හරිද? ඒතර ආයෙමත් අපි කරලා තියෙන්නේ F ගේ තියෙන sets ටිකක් අරගෙන unions අරගෙන. එතකොට මේ මොන operation එක දැම්මත් අපි F වල මොකක් හරි algebra එකක තියෙන sets ටිකක් අරගෙන නම් පටන් ගත්තේ අපි මේ අලුතෙන් හදන sets ඔක්කොමත් මේ F ඇතුලේ තියෙන්නේ නේ. Therefore all the sets we have created are also in F. Therefore this A tilde is contained.
තේරුණා.
හරිද?
හරි.
ජයනිදු ඒක ජයනී නේ.
ඔව් සර්. තේරුණා සර්.
හරි නේද? Right.
හරි.
So this A tilde has this property. Okay, it is an algebra such that any algebra which contains A will contain A tilde. Okay, so this A tilde has the following property. Has the property that any algebra containing A will contain A, will contain A tilde. Okay, so that's this property. Okay, so therefore we can call this what? A tilde is called what? A tilde is the smallest algebra containing A. Containing the sets in A. මොකද අපිට කවුරු හරි කිව්වොත් එimhe sets ටිකක් දීලා ඒකෙන් හැදෙන ඒකෙන් ඒ sets ටික තියෙන algebra එකක් දෙන්න කියලා අපිට ඔය දෙක S2 පියාගෙන තප්පරෙන් උත්තරයක් දෙන්න පුළුවන්. මොකද්ද? දැන් මම කවුරු හරි අහුවොත් මෙන්න මේ sets ටික දීලා මෙන්න මේ set තුන දීලා හරිද? මේ තුන තියෙන algebra එකකට example එකක් දෙන්න කියලා. You can give an example like in 1 second. What is it? කො තප්පරයක් ගියා.
all ඊට වඩා ලොකු සබ්සෙට් ලොකු සෙට් එකකින් හැදෙන ඇල්ජිබ්‍රා එකක් දුන්නා නම් හරි සරි words හරි
Sorry, I was in my. So what is it? Yes, I'm asking. Oh, ඒ sets ටික තියෙන obviously අපි හැමෝම දන්න algebra එක මොකද්ද? ඒ power set of formula. එතකොට දැන් මේ sets ටික දීලා මේ ටික තියෙන මේ sets ටික දීලා මේක තියෙන algebra එකක් දෙන්න කියලා කිව්වොත් that's really easy. හරිද? හැබැයි අපි මේ කරලා තියෙන මොකද්ද? මේ ටික තියෙන අර minimal algebra එක හොයලා තියෙන්නේ නේ. The one which is the smallest one. ඒ කියන්නේ මේ ටික තියෙනවා නම් අනිවාර්යයෙන්ම තියෙන්න ඕනේ sets ටික විතරයි අපි හොයලා තියෙන්නේ. So we have found the algebra which the smallest algebra which contains these three sets. Once you complete this process. Okay?
okay
Right. So this A tilde is the smallest algebra containing the sets in A. Okay? And we will call this the algebra generated by, so this A tilde is called the algebra generated by these sets in A. Okay? And we will denote it by sigma A. Okay? And it is the it is the smallest algebra containing A. So what do you mean by smallest algebra? So what do we mean by this statement?
sigma algebra
Sorry. Yes.
This
Uh,
the same which generated
sorry.
above.
මොකද්ද
The
පුතා
same
අප?
which generated above, sir.
Yeah,
The
but
same which generated above.
yes, it is the generated
Small.
algebra. So that's what we call the algebra generated by A. But what do we mean by this smallest algebra containing A? What does that mean?
Uh,
Like as a if you want to write down a mathematical statement, I mean.
uh,
If A is
having
algebra,
the
then
minimum having the minimum number of elements of all the algebras containing A. So did you hear me?
සෞම්‍ය සර් කියන එක එනවද?
නෑ සර් කියන දේ ඇහෙන්නේ නෑනේ.
මට එන්නේ
මට මොනවත් ඇහෙන්නේ නෑ.
මට
පොඩි මම දාන්න මැසේජ් නෑ සර්ගේ මයික් එක නෑ මයික් එක ඔන්න දානේ.
මයික් එක ඕන් වෙලා ඉන්නට මේ වැඩ
සමහර කියනවා
ඔව්
කියනවනේ සර් එන්නේ.
කියනවා වෙන්න ඕනේ. ඇහෙන්නේ නෑ. ඔව් පොඩි මම පැට් එකක් දාමුනේ.
එතකොට දැන් මම කිය හිටියේ මේක මොකද්ද මේ smallest algebra එක කියලා කියන්නේ දැන් කියන්නේ ඒව contain කරන මොකක් හරි ඕනම algebra එකක් දුන්නොත් මේ ඒගෙන් generate වෙන algebra එක ඒකේ subset එකක් වෙන්න ඕනේ. ඒ කියන්නේ තමයි අපි ඒ කියන මේක මෙන්න මේ A tilde ඒගේ ඒව contain කරන smallest algebra එක පුංචිම algebra එක කියන්නේ ඒකයි. කියන්නේ වෙන ඕනම algebra එකක් ඇතුලේ මේකෙන් generate වෙන algebra එකක් තියෙනවා. තේරෙනවද කිව්ව කතාව? ඒ කියන්නේ අපි ඒගෙන් පටන් අරගෙන මොනවා හදාගෙන ගියත් ඒව ඔක්කොම වෙන මොකක් හරි ලොකු ඇල්ජිබ්‍රා එකක් ඇතුලේ ගත්තොත් ඒක ඇතුලේ සිද්ධ වෙන දේවල්නේ. ඒකින්ද මේකෙන් හදන ටික ඔක්කොමත් මේක ඇතුලේ තියෙන්න ඕනේ. හරිද? So what we mean by the smallest algebra containing A is precisely that statement. Okay, what is it? That means now can you tell me to help me to formulate this? What do you mean by this?
it contain
පොඩක් හයියෙන් කියන්න දුව.
A containing the algebra if
Yeah, if okay, if F is an algebra, let's call it for any algebra, okay, for any algebra F, if you take any algebra F containing A, right? A. Then yes, නම් ටික හැම වෙලේම අමතක වෙනවා. චම්මික, right? චම්මික?
And it Hilda is also
Inside F.
contains yeah it's in there yes
Yeah. ඒ කියන්නේ අපි මේ A ගෙන් හදන්න පුළුවන් sets ටික ඔක්කොම ආයිත් F ඇතුළෙමයි තියෙන්නේ. Okay? හරි එතකොට මේ A tilde කියලා කියන්නේ ඒකෙන් හදන්න පුළුවන් පුංචිම algebra එක. Okay, this is the smallest algebra containing A. So actually this is now not A tilde, we have a notation for this. Hari, we will always denote this by sigma A, okay?
sigma right
Actually not sigma A, okay? So we will denote this by අපි sigma පාවිච්චි කරන්නේ sigma algebra එකට, okay? So let's use this alg, okay? So the algebra generated by A is this. පොඩ පොතේ බලන්න මේ sigma එක පාවිච්චි කරලා තිබ්බේ sigma algebras වලට විතරයි මං හිතන්නේ. Okay? So let's use this notation. All right?
Okay.
Do you hear me? මම ඇහෙනවද?
ඔව් සර් ඇහෙනවා සර්.
Alright.
oh sahana sir
හරි නේද? එතකොට දැන් මේ මොකක් හරි set එකකින් generate වෙන algebra එක කියන එක පැහැදිලි නේද ඔයගොල්ලන්ට?
oh
ඔව් සර්.
right? ඒ කියන්නේ ඒ ටිකෙන් හදන්න පුළුවන් පුංචිම algebra එක. එතකොට අන්න ඒ algebra එක මෙන්න මේ qualitative properties ටික satisfy කරනවා. Okay, what are the three qualitative properties? Okay, it's an algebra containing A and any algebra containing A will contain it. Okay?
oh yes sir
Yes sir.
Right. Then I want to describe this algebra generated by a set in a different way. Okay. Okay, what is it? So that brings us to a different example. Okay. Now let's fix an sample space omega. Okay. Right. And suppose that you have some collection of algebras. Okay, it's a collection. So what do I mean by a collection of algebras? So for each I,
contains-
Fi is an algebra. Okay. Algebra over the same sample space. Okay. Right. Then if I take the intersection of these guys, මට මේ intersection එක ගන්න පුළුවන් නේද? ඒ කියන්නේ මේ Fi කියලා කියන්නේ collection, each Fi is a collection of subsets, right? Intersection එක කියන්නේ මොකද්ද? මේ හැම එකටම පොදු subsets ටික, right? දුවට පැහැදිලිද? හරි පුතාලා දෙන්නට?
okay sir
හරිනේ? right. මෙන්න මේ intersection එක ගත්තොත් this is also an algebra. Now can you prove this? අපි මොකද්ද පෙන්වන්න ඕනේ ඉස්සෙල්ලම?
ඉන්ටර්සෙක්ෂන් එක කියන්නේ කලෙක්ෂන් එකේ සබ්සෙක්ෂන්.
පොඩ්ඩක් අපි පෙන්වන්න ඕනේ දැන් මෙන්න මේක ඇල්ජිබ්‍රා එකක් කියලා. අපි මේකට නමක් දීගමු. හරි? Okay. Let's say මෙන්න මේ ඉන්ටර්සෙක්ෂන් එකට අපි නමක් දෙමු. මොකක්ද හොඳ නමක් කියන්න බෑ.
F prime.
F prime නෙවෙයි F කියලා දාමුනේ.
Right.
හරි. දැන් අපිට පෙන්වන්න ඕනේ මෙන්න මේ F කියන එක ඇල්ජිබ්‍රා එකක් කියලා. කියන්නේ මේ F වල තියෙන හැම Fi ටම පොදු සෙට්ස් ටික. right? දැන් අපි කොහොමද මේ F කියන එක ඇල්ජිබ්‍රා එකක් කියලා පෙන්වන්නේ? yes ජයනි?
F කියන එක සබ්සෙට් එකක් කියලා පෙන්වන්න ඕනේ කලෙක්ෂන් එක. collection of algebras.
F කියන එක ඇල්ජිබ්‍රා එකක් කියලා පෙන්වන්න ඕන නම් මොකද්ද අපි පෙන්වන්න ඕනේ? ඇල්ජිබ්‍රා එකක් කියන එක ඩිෆයින් කරලා තියෙන ප්‍රොපර්ටිස් තුනකින්නේ.
complement එකයි intersection.
ඉස්සලාම අපි පෙන්වන්න ඕනේ මොකද්ද?
ඒකේ complement එක algebra එකක් කියලා.
නෑ ඊට ඔක්කොටම මොකද්ද complement එක ඇල්ජිබ්‍රා එකක් කියලා? No, turn your pages and look at the definition of an algebra. What do we mean by an algebra? So if you want to verify that this is an algebra, we have to verify that this F satisfies those properties.
empty set එකයි
set one universal section.
We need to show what?
empty set and
Empty set and
Sample space.
omega belongs to F. Right. දෙවෙනි ඊළඟට මොකද පෙන්වන්න ඕනේ?
set එක algebra එකේ තියෙනවා.
A කියන එක F තියෙනවා නම්
ඒක
complement එකත් තියෙනවා.
ඒකේ complement එකත් F ගේ තියෙනවා කියලා. ඊළඟට මොකද පෙන්වන්න ඕනේ?
AB කියලා දෙකක් තියෙනවා.
F වල නේ if A, B belongs to F, then
A intersection
A union B.
හරි දෙකේ එකක්. හරි A intersection B හරි A union B හරි F වල තියෙනවා කියලා පෙන්වනවා නම් ඇති. දෙකම පෙන්වන්න අවශ්‍ය නැහැ. මොකද එකක් පෙන්වුවාම අනිත් එක නිකම් එනවා මේ කම්ප්ලිමන්ට්ස් හරියන හින්දා නේ. right. හරි. දැන් ඔන්න ওই ටිකයි අපි බලන්න ඕනේ. right. දැන් empty set එක මේ F ගේ තියෙනවද?
ඒක තියෙනවා.
ඇයි ඒ?
මොකද හැම එකෙම ඉන්න ඕනේ හින්දා ඒ
right,
Fi
okay.
algebra හින්දා.
So empty set belongs to Fi for all I. මොකද හැම Fi එකක්ම algebra එකක් නේ. අපි ගත්තේ මේ algebra collection එකක් නේ. right. Therefore empty set belongs to the intersection of Fi. Okay. Similarly, omega also belongs to Fi for all I. Therefore, omega belongs to the intersection of Fi as well. දැන් කතාව පැහැදිලි නේද? මොකද්ද වෙන්නේ කියලා? right. එහෙනම් දැන් දෙවෙනි එකත් ඒ වගේම චෙක් කරලා බලන්න හරියනවද කියලා. Right. Have you done it?
Yes, sir.
What about Jayani and Chanaka?
Sure.
Jayani,
සර් ඇහෙන්නේ නැතුව
oh, කරාද?
නෑ සර් තාම කරන්නේ.
මොකද්ද දැන් කරන්න තියෙන්නේ? Yes, Jayani, can you tell me now what are we going to do? We take something from,
Something from if
yeah, so let A belongs to F. Okay, that means what? A belongs to,
A belongs to intersection of F.
yeah, that means A belongs to
F5.
F5 for every I, right?
Yes.
Hmm.
If and now F5 is an algebra, right? Therefore, what can you conclude?
And
Yes,
A complement
Ek.
belongs to
F5.
F5 for every I. Okay, just F5
Yes.
is not enough. Yeah, for all I. Okay, that means A complement belongs to intersection of
F5.
F5.
F5, that is precisely F, right? So what have we shown? That if A belongs to F, then A complement also belongs to F.
Hmm.
Right. Now the next one is exactly the same thing. Can you do it on your own? What do we have to show next?
If A and B
Belongs to F, then we have to conclude that A intersection B is in F, right? Right. Can you complete this?
Okay. Sir.
Uh, Chanaka, can you tell me what you have done?
AB කියන සෙට් එකක් F වල තියෙනවා නම් අපිට කියන්න පුළුවන් ඒක F5 වල තියෙනවා කියලා.
මොකද පුතා අපෝ කියන්නේ? Then
AB කියන සෙට් එකක් F වල තියෙනවා නම්
oh
then කියන්න පුළුවන් AB සෙට් එක F5 වල තියෙනවා.
oh කියන්නේ මොකද F කියන්නේ මේ හැම එකේම තියෙන sets ටිකනේ නේ. For all I. හරි. Then
එහෙනම් A union B තියෙනවා F5 වල.
okay, I'll go with A intersection B, okay? ඔයා කියප එකත් හරි පුතා. You can either go with union or intersection, but I'll take the intersection to be consistent, okay? Then A intersection B belongs to Fi for all I. Why is this? Because
F5 is an algebra.
Fi is an algebra, right? Right. Okay, thus
then the intersection B තියෙන්නේ F ඇතුලේ.
F factorial, right? Because it is the intersection of all
Intersection of
Fi. Right, so this now just verifies that F is an algebra, right? So if you take an intersection of certain collection of algebras, you again get an algebra. Harida? Right. Then
Yes,
let's
sir.
go back to our definition of this algebra generated by a set. Okay. Now, okay, let A be a collection of subsets of so this is a subset, sorry, this one, right? Script A, okay? This curly A is a collection of subsets of omega, right? So this is some collection of subsets of omega. All right? Harida?
Okay, sir.
Harine, right. Then we know that there is something called this, right? Algebra of A is the algebra generated by this, right? So which is the smallest algebra containing A. All right?
Yes.
Hadid,
හරි සර්.
Tamika, Taminda,
Okay, sir.
right. හරිනේ, right. දැන් අපි දන්න එක විදියක් තමයි මේක කොහොමද අපි construct කරන්න කියලානේ අපි බැලුවේ. sets වලින් අර create කරලා ඒ කියන්නේ how to construct this by using some hands-on computations, right? Now here is a different way which I call a qualitative description of this algebra. Okay, what we just saw before is a quantitative description in the sense that we are going to compute each and every set in this algebra starting from the sets in A. Okay, but here's another way, okay, to understand this algebra. Okay, so this is equal to the intersection of all the algebras that contain A. In fact, I want to put this as a
What my
claim.
hand?
In fact, I want to put this as a claim. You hear me, right?
Okay, sir.
Right. Okay, so this is another way of thinking of the algebra generated by a collection of sets. It's the smallest algebra containing A, right? And it is in a different way. It's the intersection of all the algebras containing A. Now this makes sense because just before we showed that if we take a collection of algebras, then their intersection is also an algebra, right? Is also an algebra. And therefore, this makes sense. All right. Jayani
Okay, sir.
and Chaminda. Chanaka, sorry. Chanaka.
Okay, sir.
Right. Okay.
Chammika
Now,
sir.
but still we have to verify this claim.
ඇහෙනවද සර් මාව?
මට ඇහෙනවා මාව ඇහෙනවද?
Alright.
හරි. Right. But
Okay
still
sir.
there is
වෙලාවකට
some-
එකක් එන්න.
ඇහෙනවා මදීද මාව?
Okay sir. ඇහෙනවා sir.
හරි. Right. Okay. But still there is something for us to prove here. Okay. I want to claim that this intersection is actually equal to the algebra generated by A. Okay. Right. Now, how do we prove this? Okay. Right. First of all, we know that if we take the, let's call this intersection. Okay. What is this intersection? Is the intersection of all algebras containing A, right? Okay. Right. First of all, we know that there is this intersection is non-trivial. I mean non-empty, right? This is an intersection. Okay, the intersection is I mean, so maybe here's the point. Okay, now this intersection is an algebra, but there is a concern even before we go into this even before we go into computing this intersection. Okay, what is that question? First of all, we need to know that are there any algebra at all satisfying these conditions, right? Because we don't know whether this intersection is vacuous, right?
Vacuous means sir?
In the sense that there are no such algebras. මෙහෙම algebras එකක්වත් නැත්නම් අපිට මේ intersection එක construct කරන්න බෑනේ ඉස්සල්ලාම. ඒව contain කරන ඔක්කොම algebras වල intersection එක ගන්න කියලා කියලා තියෙන්නේ. හැබැයි එහෙම ඒව contain කරන algebra එකක්වත් නැත්තම් So how do we know that this intersection is non-vacuous? How do we know that there is at least one such algebra for this intersection to be constructed, to be non-vacuous? Okay, so let's say you can take the intersection of an empty collection, but that's something that we want to avoid here. Okay. So how do we know that there is at least one such algebra? Do we know an algebra which contains A? Then ටිකකට කලින් ඔයගොල්ලෝ උත්තරේ දුන්න මට. Is there at least one algebra containing A? Yes, මොන හරි කවුරු හරි කිව්වනේ. Chammika, is there an algebra which contains A? So for any given A. Then චුට්ටකට කලින් උත්තරයක්.
Power set of A.
Power set of A, right?
We don't know sir because
Power set of A is power set of omega. power set of
Yeah.
omega is
So
always it's an algebra and it contains any this A, right? Because any collection of
this
subsets is there.
Hmm.
You got the point, right, Jayani?
Yes.
Okay,
Yes, sir.
right? Because how do we know this? Because power set of omega contains A and is an algebra, right? Is an algebra. So this intersection is non-trivial. There is at least one such algebra, okay?
Hmm.
So there is at least one, but now we have to find all of them and take the intersection. Are you with me?
Yes.
Yes, sir.
Right. So now we can write down a proof, okay? Okay, we will first note that the intersection, okay, A uh, is is a non-empty intersection, okay? How do I write it? First note that there is uh, P omega containing A. First note that P omega is an algebra containing A, and hence uh, there is at least one such algebra uh, in the intersection. Okay, right. Now we
Hmm.
consider the intersection of all such algebras. Okay, all such algebras uh, that contain A and call it what can we call it? G. Okay, so G is what? The intersection of all the algebras containing A. Okay, so I will emphasize by writing this superscript algebra by saying that F is an algebra. Okay, right. Now my goal is to show that G must be equal to this one, right? That's my claim. So this I want to show that G is equal to this. Okay, and what do I know about this one? This one is characterized by these properties, right? Okay, where is it? Here we go.
Right.
These properties, so this is algebra, right? And it is an algebra containing A, right? And it is the smallest algebra containing A in the sense that for any algebra F, this one is in F. Okay, කවුද යනු හරින්නේ?
Okay.
Right.
Marisa again.
අවන්නේ නිදිමත එනවනේ මේ වගේ කරනකොට. Right. Okay, now how do we prove this? Right, this is what we can do. දැන් බලන්න ඉස්සෙල්ලාම හරිද, note that right? A tilde is an algebra containing A, right? Or what we call this one, right? Okay. හරිද?
හරි සර්.
හරි සර්.
right. එහෙනම් මෙන්න මේක මෙන්න මේ මෙතන තියෙන ඒවායින් එකක් නේද? Thus algebra of this one is in the intersection. So that means not only the power set of omega is an algebra containing A, we also know that this is an algebra containing A, the one we constructed using those operations. Okay.
හරි සර්.
right.
right. එහෙනම් මේ G ගැන මොකද්ද කියන්න පුළුවන්? දැන් ඔන්න G කියලා කියන්නේ මේ වගේ ඔක්කොගෙම ඉන්ටර්සෙක්ෂන් එක. හරිද? මේක ඇවිල්ලා ඒ ඉන්ටර්සෙක්ෂන් එකේ තියෙන ඒවායින් එකක්.
Subset of
Very good. This one is a subset of this one, right? Right. On the other hand, අනිත් අතට බලන්න මෙන්න මේක. On the other hand, right? Now G is an algebra. හරිද? ඇයි ඒ? It's an intersection of algebras, right? Because it is an intersection of algebras. Okay? Not only that, now G is the intersection of all the algebras which contains A, right? Right? But if you take a collection of sets, okay, all of them containing A, then what can you say about this intersection? Right? All of these sets, all of these algebras contain A. Then what can you say about the intersection? Can you say that the intersection also contain A? මේ හැම F එකකම Aව තියෙනවා නම් ඒ වගේ intersection එකක්
algebra.
තියෙන්න ඕනේ නේ. Right. So G is an algebra containing A. Right? Therefore, G is an algebra containing A. හරිද?
හරි සර්.
right. හැබැයි දැන් මේ කියන්නේ මොකද්ද? The smallest algebra containing A. ඒ කියන්නේ මොකද්ද? Any algebra that contains A will contain this. Right? So if G is an algebra containing A, then what can you conclude? This is the smallest algebra containing A. So this is the smallest algebra. Yes?
Is also
Is also in G.
Yeah, this is in G, right? This is because algebra of A is the smallest algebra containing A. Okay, this is exactly what I told. Remember, make an කලින් මම ඒකයි මේක emphasize කරලා කිව්වේ. හරි? smallest algebra කියන එකේ meaning එක තමයි මොකද්ද? මේක contain කරන ඕනම algebra එකක් ගත්තොත් මේක තියෙන්න ඕනේ ඒක ඇතුලේ. හරි? මොකද අපි අර operations apply කරේ those operations are closed in an algebra, right? හරිද?
හරි සර්.
right
right. දැන් අපිට බලන්න අපිට මොනවද ලැබිලා තියෙන්නේ කියලා G කියන එක මේකේ subset එකක් කියලා ලැබිලා තියෙනවා. හරිද? අනිත් පැත්තට ඒක G වල subset එකක් කියලාත් ලැබිලා තියෙනවා. එහෙනම් 1 and 2 what can we conclude from 1 and 2?
ඒක algebra.
Sorry?
those two are equivalent sum.
It is close to I.
G must be equal to algebra.
Yes, exactly. Right. So G is equal to the algebra generated by this. That means the algebra generated by this is what? Is the intersection of all the algebras that contain A. Okay, so this is a qualitative description of the algebra generated, right? So you can think of this as a qualitative way of describing it, but the constructive approach is to is the description we gave at the beginning. Are complements අරගෙන intersections අරගෙන so you go through that process and close it by those operations. So then we can create an algebra containing those sets, and that creation is equal to taking the intersection of all the algebras containing that set.
Right.
Okay, so then make again හිතන විදිය තේරෙනවානේ. So there are different ways of thinking of it, okay, which where both of them are equal. One way to think about this is as a process of creating sets out of these operations, starting with the initial collection of sets. The second way, which is equal to that but slightly different in construction or description, is to describe it as a intersection of all the algebras containing that set, that collection. Okay, in fact this is the way to know that our process will end eventually. Okay, so when we continue this process, eventually I don't know, maybe probably after infinitely many steps, okay, but there is an algebra that satisfying this thing. Okay,
සන්තිමට ඇහුන්නේ නැහැ සර් මම හිතන්නේ.
ඒ කියන්නේ අපි දන්නේ මේක finite steps ගානකින් අතර වේද කියලා, but okay, we might have to continue for infinitely many steps, but there is an algebra containing this set, which is which we can claim to be the smallest algebra containing this set, this collection. Okay, Jayani, is this all right?
Yes sir.
Okay, Amit and Chanaka. Right. Now I think you should look into the exercises and also to the past papers. Okay.
Right.
Okay. Jayani and Chana can come with me. All right?
Yes.
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 Right. Before I finish, 10ට ඉවර කරන්න ඕනේ මේක.
Oh, sir.
Right? Before I conclude, now let me ask you, why do we need the notion of an why do we need the notion of an algebra? Yes.
අපිට සර probabilities define කරන්න හදනකොට තිබ්බ ප්‍රශ්නෙට නේද සර් අපි ඔක algebra
That's
වලින්
right.
notion එක
Remember
කරා.
now, yeah. So when we talk about the probabilities, we should be able to compute the probability of a complement, and we should be able to compute the probability of an intersection and a union. So these sets better be in the collection of sets for which the probability is defined. Okay.
Hmm. Yes, sir.
We need the sets for which probability is defined to form an algebra, right?
Hmm.
But we know that we are not going to be satisfied with finite intersections or finite unions, right?
Yes.
And in fact, what do we need? We need what?
Infinite.
Yeah, infinite is not quite appropriate. How do
Yeah.
we
Intervals.
no, no, we are talking about arbitrary sample spaces, but we are, it's not enough to consider finite unions, right? We sometimes want to consider what sort of unions.
Yes.
They are infinite unions, but not like arbitrary infinite unions. What sort of unions do we want to consider? No, you should recall from our previous examples.
Sequence.
Yeah, so we have a name for those.
Sequence.
Yeah, sequence like 1, 2, 3, right? So what do we call such a sequence, such a union? A countable union, okay?
Countable. Yes.
Right? Dua and Chaminda,
Yes.
Chanaka, okay?
Okay, sir.
Right. However, right, for to extend our theory, right, we need such collections to be closed under countable unions, right? Right. So we want to extend the notion of an algebra to include countable unions, right? Thus, we need our notion. We need to extend, right? Our notion of an algebra to include countable union. Okay, and this extended notion is what we call what? Yes, this extended notion is what we call a
sigma.
sigma algebra.
Yes.
Okay, so what is a sigma algebra? So it's a sample space. Okay, then a collection of subsets of omega, that means a subset of p omega, right, is called a sigma algebra, called an sigma algebra, if it follows the if what? First of all, what should it satisfy?
Uh,
Empty
Yes, dear.
set and sample space.
Yes, empty set and omega must belongs to F.
Hmm.
And then
A is in
ඇහුන්නේ නැදුව.
A is in F, then A complement is
Yeah, if
in
A is in F, then A complement is in F. And then finally,
A and B are in F. Then
මොකද්ද දුව?
if A and B are in F, then A
දැන් ඒක මදි.
Hmm.
That will be same as an algebra, right? Now we want it to be
if A
based on the countable unions. Countable unions. Yes? AI,
AI is in F.
right, for all I in N, okay? Okay, these are indexed by natural numbers. That's countable, okay? So this is what we mean by countable. Okay, all of these are in F. Then union AI is in F. Remember here the indexing set is natural numbers. That is why, that is how we emphasize that this is a countable union. Okay, right. So we will continue from this point next when we meet next time. So is it going to be next week?
Hmm.
So let's make it next week then. Okay. Meantime, can you go through the node, go through the book and try to understand what is covered about sigma algebras, and try to
Yes, sir.
complete the problems. That
Yes,
will,
sir.
it will be much easier for us, right?
Mhm.
Okay.
Okay, sir.
Right.
Read the book. The problems. Okay. All right. Then we will meet next week on Wednesday. Probably we'll fix a time before. It all depends on the situation, right? How it improve, whether it gets worse or improve. So we'll leave it open at this moment. Okay.
Right.
Right. Then I'll see you next time. මේ ටික බලන්න. හරි. එතකොට අපිට මේක ඉක්මනට කරන්න පුළුවන්. මේ එකල එතකොට වැඩිපුර problems කරන්න පුළුවන්. Practice කරන්න.
Yes, sir.
Right. Right.
Right.
Thank you, sir.